Hello and welcome to my YouTube channel. My name is Thomas and today we are going to take a look at the so-called game changer in 3D printing. I got myself a Bambu Lab, to be more specific the P1P. Since I love to tinker around a bit, upgrade stuff and also enjoy to put a personal touch on the stuff I own, I thought the P1P might be the way to go for me personally over the X1. If that decision was correct and if I would recommend this machine after around 6 months of daily usage will be talked about later in this video. And of course, I also ordered a so-called AMS unit to get the possibility to print with up to 4 colors in one print. But I will mainly focus on how to turn this mousy looking cube into a personalized, fully upgraded printer that's thanks to easy Hardened and Extruder upgrades capable of also printing abrasive filaments. And besides of having fun upgrading, I will also talk about noise levels, which issues occurred, especially the ones that can't be solved at the moment, and the big strength of this machine and the company behind it. And I also have great news for all people that love to use extruder filaments. Thankfully, they provided a discount code for all of my subscribers and viewers to save 20% on all of your orders. This code will be shown a bit later around the middle of the video. And similar to my last video, there's again the chance to win something. The choice will be between a Bambu Lab Hotend, 1 kg of filament, or if the winner doesn't own a printer, an Amazon gift card. To participate, you simply have to leave me a comment down below. Especially leaving me feedback would be super appreciated, since that helps me a lot on improving for future videos. Also, if you liked that video in the end, please consider a like and subscribe my channel for free so you help me out a lot and don't miss on upcoming videos. All the links for the printable modifications I used are shown down below in the video description. And with that, let's get started. After removing the outer packaging, we can spot an accessory box inside the printer. In this box we can find 1 kg of matte white PLA, a pretty standard Bowden tube with its associated anchor or connector, 2 hex keys and a needle to unclog the nozzle, some screws and a blade for a printed scraper, thermal grease and 2 replacement wipers. These are needed since the Bambu Lab always cleans the nozzle with the wiping against these wipers after a filament change or starting a print job. Further on we have a replacement 0.4 Hotend, thermal grease and more stuff needed for the Hotend installation. Also we have some screws for the enclosure, the filament holder, a power cable and of course the screen. Before we get started with our Bambu Lab, we first have to free the toolhead from these cable ties. After that we can remove the cardboard protection and also this foam inside of the lovely cold poop chute. Most importantly, there are 3 screws securing the build plate at the bottom of the P1P, also marked with red stickers. These screws need to be removed before turning on the machine first. The white foam underneath the build plate can be removed after the first calibration. Installing the screen is pretty straightforward. The cable will be inserted correctly at the screen itself, then bent to the right as you can see, inserted into the frame of the printer and pushed to the left until it snaps in. At the upper right side of the printer's back, we now install the anchor for the PTFE tube. This can still move afterwards to avoid too much tension to the Bowden tube depending on the printhead's position. Now we connect the tube to the printhead and the anchor and connect the tube with these black clips to the printhead's cable. Also on the backside we install the filament holder using 2 marked screws. Now we are basically ready to turn on the printer and connect it to our network. In my case this worked super smooth and surprisingly quick. If you think about an enclosure or at least side panels, there are plenty of possibilities out there. 4 can be downloaded from Bambu Lab's website directly. In my case I wanted to try the Pixelplate since I'm a huge Legend of Zelda fan and these panels gave me the chance to create a sweet Zelda related design. But if you want something different, you can take a look at printables to find something that suits your needs. For example, this arc enclosure is very popular within the community, but you will need custom acrylic panels if you want it to look the way it was intended. As pre-order bonus, I already got the auxiliary part cooling fan, an LED strip and the chamber camera. For the P1P cam I want to mention that it records and monitors with only 0.5 frames per second. In my opinion it's still alright and you can produce cool time-lapse videos with it. Thanks to the speed of the Bambu Lab, all printable modifications are done pretty quick. These include for example the frame for our side panels and also the auxiliary fan holder. Since I plan to use the X1's glass top cover, we also need some sort of adapter for that. I went with this version that allows ventilation, but there's also a version with sliders so you can open or close those spacings to higher or lower the chamber temperature. And of course we need our pixel plates and their screws. And if you're like me and want to use every spot on your pixel plate, get ready to print a lot of these pixels. Bambu Lab offers either round or square ones. Since I couldn't decide, I just went with both. And here you can see the amount you need for just one side of your printer. And for me, the sound of removing these pixels from the build plate was also awesome. And of course, we also need a holder for our LED light. And with these parts, I thought my modification will be complete, but then I came across the idea to install the X1's Glassdoor. And since Bambu Lab also offers a mounting kit, I wanted to give it a try. And since I already make an P1X or X1P, I also thought, why not just add the cable chain too? If you also want to install the X1's Glassdoor, I'd recommend to start with this first. Since we have to remove the frame's cover, we unplug and remove the screen, loosen these two screws and also one, as you can see, pretty hidden one on the inside of the frame. After that you can just loosen or remove the cover to get access to the upper hinge's mounting spot. After installing the upper hinge with two screws, as you can see here, you just reinstall the cover and the screen. The lower hinge is, well, a different story. Bambu Lab has a video on their channel for replacing this part, but they tell you to bend the inner side of the printer's frame with a hex key a bit to get access to the left screw. I definitely wanted to avoid damaging my printer, so I just managed to slide the hinge in place and secured it with only one screw. To be fair, this works extremely well and I'm not afraid that anything could get loose over time since the Glassdoor is pretty light. With 4 of these screws in total, we connect the glass plate to those hinges. At the right side of the printer's front frame, we also add the self-adhesive damping or sealing stripe. And to stay close, we also need those two magnets, which are meant to be mounted on the door's inner frame. Since the P1P's upper frame cover is smaller than the X1's, we end up with this little gap. But we can close this gap if we use a printed cover that will be slided onto the door. Now we finally take a look at the pixel plates. Therefore we connect the 4 matching panels for each side and then we start adding our pixels. I'm just going to speed up this process a bit so you won't get bored too much. To install these plates to our printer we first need to add the printed frames. Therefore we use spots like this one at the front and the upper inside of the P1P to fix the frame with the screws. Before adding the last, in my case the rear pieces, we simply insert the pixel plates and then secure them with the last piece of our frame. The rear frame will be secured with those 4 screws on the outside. I was pretty stunned how that design turned out, while I have to admit that my idea of using a concentric first layer to get a cooler shading worked way better with the square pixels compared to the round ones. Next on the list is the auxiliary fan that requires a printed holder. I went for a special design that also uses melting threads. One reason for that was that I simply enjoy melting these things into prints for some odd reason, and the second one is simply again in stability and durability. But there's also a version of this file where you don't need these threads. After adding double-sided tape on the top of our holder, we can add our fan. In my case I added washers since my screw heads seemed a little bit too small for the job. Before you put the fan in place, you may add some double-sided tape on the top of the fan to avoid vibrations later on. At this stand we place our fan and secure the entire thing with 2 screws at the bottom of the printer. To connect the fan we first have to loosen all screws that hold the rear cover in place, remove it and get access to the board. I secured the cable on this spot with double-sided tape to prevent it from hanging down and look ugly later. Then we guide the cable through this hole in the frame to the back side and insert it into the right plug you can see right here. If you need a better grip or feeling, you can use pliers as I did. Then we just install the rear cover again and we can head to the next step. And this step leads us to lighting. Again, I refuse to use Bambu Lab's file for the holder, since I think that this position isn't just a bit weird but would also cast shadows on the build plate to the X-axis. With this version we can avoid that issue, get a better look, and we won't get into trouble when we want to install the cable chain a bit later. Installation is super easy, just put all the parts together, insert the LED strip, pull the cable through that open spot and add the cover printed out of transparent filament. Next to the cable channel, which is quite handy by the way, we also see those two knobs or clips. With these we can mount our lighting right above the AUX fan using two holes in the frame. Regarding cable management, I noticed that there is a channel in the camera's housing that suits perfectly to hide our LED's cable. And filming that camera installation wasn't too easy, but thankfully my SD card decided to delete itself afterwards. But luckily Bambu Lab offers a pretty great YouTube channel providing tons of tutorials and tips, so I would say we just take a look on their camera installation instead. But don't forget to put your LED's cable through that channel before you mount the camera, because this can't be done later since the camera will be installed, like shown here, due pushing it against the frame until it locks in place. The self-adhesive cable will now be applied along the frame until it reaches the very top. There we have to bend it on two marked spots and shove it underneath the front plastic cover. Right behind our screen we can connect the cable. Our LED's black and red cable can now be guided upwards through those channels until we reach the same board behind the screen and plug it in right here. Then add the cover again you had to remove previously and we finish this step. The holder for our glass top cover is the next super easy upgrade on the list. You simply have to connect all parts at the right position. The only thing I noticed was that if the printer moves super fast and shakes a bit, this riser might slide around on the printer. To prevent that, you may use a bit of double-sided tape underneath when putting it on your printer, or add some melting threads so you can connect it to the printer's frame at the rear end with two screws. After that, we simply put the glass plate in place. In my opinion, it not just looks awesome, helps for thermal isolation, but it also protects the X and Y axis rods from dust. The only small disadvantage from this solution is that we have to find another way of passing the PTFE tube to the rear end of our printer. Therefore we use this gap right here, and to avoid the chance of excessive wear on our tube due friction, we use for example this printed bracket. But if you're also interested in installing the cable chain, you can skip printing this bracket since the chain comes with a rubber one already. And so let's get started with the cable chain. Therefore we first have to remove the 4 screws on the rear end of the print head. Then we can remove the rear cover to gain access to the toolhead's cable. Then we have to remove this rubber thing right here and carefully cut it with a box cutter for example along the cable so we can remove it. Instead of this rubber we now have to install the cable chain's bracket. This needs to be installed as you can see right here until it clicks in place. Now put the cable into the chain, mount this big cover at the inside of the printer's frame and connect those two parts. And this cover is the reason why we placed our LEDs further down. Bambu Lab's LED housing would sit exactly right here and would be in our way right now. Now insert the PTFE tube to this clip at the chain and connect it with this connector. Secure it with the clip and pass the tube through the rubber grommet. But right after I finished the installation, myself and everyone else that bought this chain got an email from Bambu Lab which stated that this cable chain might damage the printhead cable of the P1P, since it was designed for the X1. Therefore, everyone that got this chain also got a free new printhead cable for the P1P. This arrived here pretty quick, but I have to admit that I still use the stock cable since it works flawlessly for hundreds of hours so far, and if there's an issue one day I can still swap it. Anyways, I just don't want to hide that information. Also in Bambu Lab store you will now see this little warning right here if you click onto the cable chain. The installation of our AMS unit is mostly done at the backside of the printer, where we also find the belt tensioners. This thing is the so-called filament buffer, which will be placed right here on the rear plate, and the tube will be inserted into the coupler above. The 6-pin cable is used to connect the hub to the AMS itself. And there's also a 4-pin cable included that connects the buffer with the printer. Now we only connect the tube coming from the AMS with our buffer, and so we get a closed filament feeding circle. And for those interested, the buffer's job is to tell the AMS how much filament is on the way to the printhead using the spring, which also measures the tension inside the PTFE tube, and at a certain tension the buffer tells the AMS to shove more filament into the tube. If we close the lid of our AMS, it is airtight to protect the filament from dust as well as moisture. Up to 4 1 kg spools can be placed inside, but sadly some companies produce spools that are too wide to fit into the AMS. Different to the X1 or X1C, where you can use the touchscreen on the printer, the AMS on the P1P needs to be controlled via Bambu Studio. Here we can assign our filament type, color, as well as the so-called K value to each of the 4 slots inside the EMS. We can also load and unload filament as well as have a look at the humidity inside the EMS. When setting up the EMS for the first time, you need to add the included desiccant bags to keep humidity low later on. But over time this may stop working, and here we have a place to control that. Furthermore, the EMS won't just notice when it runs out of filament, but also notice when you insert a new one. After inserting around 2 cm, the EMS will start loading the filament automatically. While it looks super cool, the sound level may be a bit annoying for some sensitive users. And since multicolored prints are super easy now, I wanted to present you the discount code for extruder filaments using multicolored printed letters, which I think look pretty awesome, and it's a cooler way than just fade the code in. So with EX_TMBDY, you will save 20% at your purchase at Extruder Filaments. Since the P1P neither comes with a hardened steel hotend or extruder gears, we have to upgrade those parts if we want to print abrasive filaments. Both parts can be purchased at the Bambu Lab store for a pretty fair price. To upgrade our printhead, we first have to remove the magnetic cover as well as the PTFE tube on top of it. To remove the hotend, we carefully unplug the connectors, remove the 2 screws holding it in place, and then we can simply remove it by sliding it down. To remove the extruder unit, we first have to loosen this black screw to turn away the filament cutter. After removing the screws that hold the extruder in place as well as unplug the fragile connector, we can remove the extruder. Now we need the small hex key that's included with the P1P and also the upgraded gears. After removing the housing's screws, we can remove that cover plate to get access to the gears. The yellow one can be removed by simply pulling it out. Then we have to lose the tensioner spring by unscrewing the black screw on top a bit. In my case, the spring came off at its own anyways. The second gear can also be removed by simply pulling it out of the housing. As you can see here, the hardened steel is way darker compared to the stainless steel from our stock parts. Reinstalling the gears is pretty straightforward. Add the grey gear, insert the spring back in, tighten the tensioner screw a bit and also insert the yellow gear. Then give it a short check if everything moves freely before adding the cover plate again and fully tighten the tensioner. Regarding the hotend, we have 3 options. First, we can simply buy a fully assembled one. Second, we only buy the hotend itself and reuse the thermistor, heating cartridge, silicon sock, as well as the cooling fan from the stock hotend. Or third option, we buy all those parts spare together and build a fully assembled new one. For those interested in building the entire hotend or learning how to replace certain parts in case of a defect, I will now quickly show the full assembly of that hotend. First, we add a bit of thermal grease at the backside of the hotend as well as at the hole for the thermistor before we insert it. Then we add the white heating cartridge and secure both parts using this aluminium clip. But take care that this clip has a small curve that protects the thermistor cable from any damage, so be sure to insert it correctly. At the heatsink we have a small tunnel that's used to guide the cables through. Now add the silicon sock before heading to the cooling fan, which will be screwed in place using the 2 threads right here in the heatsink. Back at our printer, at first we insert the extruder and secure it with the screws again. Reinsert the filament cutter and also secure that one with this small black screw again, and then carefully plug in the connector on top. Now we slide the hotend in place, secure it with its 2 long screws, plug in all the connectors carefully including the run from the front cover's fan before we add the magnet cover, which means we are finished with the upgrade. Next to the absolutely impressive part cooling capabilities, the easy way to upgrade, as well as the well-working profiles in Bambu-Slicer, I found some more points I would like to quickly talk about. And therefore I'd like to start with the by far worst thing on these machines. To me it is such a big deal because there is still no general way of getting rid of it. Overall the print quality is outstanding, but as you can see here at the left side of the object, you can see those ripple-like artifacts. It may look like ringing or ghosting, but it's not the same, since those waves occur on the entire x-axis, even on round objects, no matter speed, material or anything else. Here you can see that the y-axis looks nearly perfect, while the x-axis looks pretty awful. For months I'm working on a solution now with the support and other users, but there's still no general solution in sight. Plus it's not a P1P only issue, this can also show up on the X1 variants. The next issue that can also show up on both models is the bent heat bed, or banana bed as some people call it. From those that checked their bed, there's a pretty big number which found their bed to be bent as well. In my case I had multiple spots that aren't flat. After checking data, the support sent me a new one pretty fast, but as you can see here the replacement bed also looks even worse. In a worst case scenario, prints that need to be attached together might end up looking somewhat like this, since the object always follows the build plate shape, and if that's bent, your object is also slightly bent. To be fair, users that don't build such things might not even notice a slightly bent bed at all, but it seems that Bambu Lab slowly gets rid of that issue with the new version of the heatbed. Some rumors also occurred that Bambu Lab checks each heatbed now before sending it out, so hopefully we won't have that issue anymore soon. And since I'm currently talking about the company, I want to point out my honest, very positive experience with the support. The responding time was mostly within hours or at least a day, and no matter if I had AMS issues, that x-axis problem, as well as regarding my banana bed, they showed up very cooperative and helpful trying to solve these issues. This small skull from my intro brings me to the next topic. It's not a negative thing per se because there's technically no other way, but with the AMS we can have a lot of wasted material. That skull is a good example for a super wasted print, since on nearly every layer we need a color change, why we end up with a few hundreds of them, which leads to a lot of wasted material. The waste happens due to a certain amount of material that's used after a color swap to clean the inside of the hotend from the previous color. Depending on the object and the amount of objects on your build plate, it may happen that you waste more material on color changes than you use for your print itself. This skull weighs about 57 grams, but the wasted filament is way more. If you'd add 10 skulls on the build plate, you would end up with 570 grams of printed material, while remaining the same amount of wasted filament, which is 190 grams in my case, since the number of color changes would stay the same. So it's definitely up to the user to work more or less thrifty with that system. If you invest some time in testing, you can learn how much filament purging is necessary to save even more material. Having the print's orientation and also model itself in mind, like this Harry Potter logo where you just need a handful of color swaps, will also help you saving material and therefore money. Next thing I want to point out is the time, because the AMS will have a huge impact on your print time. Again, I will show you my extreme example using the skull. One color would take around 2 hours. 2 colors, like I printed it, will take around 13 hours, and if you would add a third color, it would make over 1 day to get it printed. And also the used filament that you can see here in the slicer's preview is pretty impressive. But as cool as it is, as always if something fails to work, it gets a bit frustrating. In my case, the AMS wasn't able to pull back the filament from the toolhead pretty often. Here in slot 3 the spool was simply stuck for no reason, and after moving it by hand it suddenly worked again. Support told me to swap the so-called first stage feeder from slot 3 with slot 4, which helped a few days before the issue occurred again. Then they immediately sent me a new feeder, which worked well for over 2 months now. So also with a Bambu Lab you may need to tinker around a little bit. While you shouldn't use cardboard spools inside the AMS, you can still do it by adding tape or printed edge covers to the spool. Another way are these pretty cool reuse spools. You get 4 of them when you buy an AMS, or you can buy them separate or even print your own ones. A cool thing is that they match the size of, for example, polymer filaments. So if you carefully remove a side plate of the cardboard spool, like I show you right here, insert 1/2 of the reuse spool, turn it over and repeat the procedure, and then lock the spool's halves into place, you can simply use the entire spool inside the AMS. But let's get back to our printer. With speed, there comes sound, and that's why the Bambu Lab is for sure not a Ninja 3D printer. To get a feeling for what I mean, I have a few short sound examples for you. And talking about speed, I have to admit that I'm one of the few people that doesn't seem to have issues with the P1P screen. It's reacting pretty quick and also the menu works quite well. Which also works great is the print speed change via the screen. Silent means 50% of the slice print speed, standard 100% or normal speed, sports mode 124%, and ludicrous at 166%. And this leads me to the maybe most obvious plus of this machine. Its speed. You can print with up to 500 mm a second. This G-Ride infill is printed with 280 mm a second, so just a bit more than half of its maximum. But be aware that not every filament is capable of such speeds. That's why I barely use faster speeds than 300 mm a second. This outer wall was printed right here with 200 mm a second and still looks fantastic. So regarding the low price of this machine, that's a huge plus. And it's even better if I can't just print super fast but also super good. This dragon, for example, worked super well. All joints are perfect and for 0.16 layers the surface looks awesome to me. Same story with this crocodile, no raft, no brim, nothing, just a standard profile. And even this bust that required a lot of supports, and also this cool figure right here turned out absolutely gorgeous. Something that's often underestimated is the support structure. The way Bambu-Slicer generates them and the printers capable of printing them is awesome. I only used 0.1 mm top distance and still you can remove the support with ease. After missing some features at the beginning, Bambu Lab catched up on them by providing updates very quick. Now working with the Bambu Studio Slicer as well with the printer itself make a lot of fun. You can monitor your print using the camera, control the printer in terms of printed position, temperatures, mapping the AMS and also run calibrations. Which also works great is adding colors in Bambu Studio for multicolored prints. At the top right of the screen you can either add text or paint the object. You can paint like using a pen, color topography, paint entire layers, or what I use most, color certain faces. That's how I made this Harry Potter thing right here. Everything that's a background was selected using the blue color. Here on the left side you can check your purge material amount called flushing volumes we talked about before for each color swap. Using the autocalc function may be a bit wasty, but it's on the safe side to avoid color bleeding. And talking about this software, I also want to mention the Bambu Lab wiki. For nearly every issue, information or tips for slicing settings you will find something in here. And that's nearly everything a beginner would or can need, and it's a huge plus for me that you can simply educate yourself this way. If you're willing to educate yourself for sure, and that's something I'd really recommend since I often see pretty weird questions or posts around the internet that could be answered with this wiki within a minute. Owning a Bambu Lab means you can print right out of the box within 15 minutes, but it doesn't mean you don't have to learn something about printing, different materials and also some physical aspects, so you can solve common issues by yourself. Finally, I would say if you don't really need a touchscreen including a bit faster processor, lighter sensors, which I haven't missed even 1 second, or an out-of-the-box enclosure that comes with a chamber temperature control, and maybe even enjoy tinkering around and get a personal touch to your machine, you would have a great time and loads of fun with the P1P. Either sending sliced files to the printer as well as printing directly from the SD card works very well since recent updates. The build plate, especially the high template, works extremely well, and even with all its features, this machine is built pretty compact. And what also surprised me is that the replacement parts are super fair priced, and after printing over 50 different materials and brands, I can say that there's nearly nothing this printer couldn't handle. I hope that I was able to guide you through some upgrades or maybe provided some informations that help you decide when printer shopping. As mentioned before, I would be super happy to get your feedback and opinions in the comments, which will automatically lead you to enter the giveaway. The winner will be drawn on the 1st of August. If you enjoyed the video, please consider leaving a like and also subscribing to my channel for free, so you don't miss up on upcoming tutorial videos and helping me out a lot. I hope you have a wonderful day, stay healthy, and we see you in the next video. Cheers, your Tom.